Hello everyone. Today I would like to present a sensor on how an Arduino interact with the sensor signal. We look at today's learning outcome. We're going to study the characteristic of the output voltage of sensors. Apply the voltage divider rule for the Arduino programming, and also apply the ThinkerCAD to analyze the digital data in your C program based on the sensor output. Now we look at this Arduino Uno. So we can see that they are the 6 pins from A0 to A5. These are the pins which is an analog signal. The incoming, it is able to read the incoming signal in terms of analog between 0 volt to 5 volt. It will vary changing this around or this voltage. And D0 to D13 actually is a digital input and output sensor. You use a digital write to assign as a 1, meaning the output will become a 5 volt. Use a digital write to write as a 0 or low, actually the output signal will become a 0. So digital is normally to control other actuators or the other transistor, relay, and any other driver. Now we look at the market of the different operation voltage of the sensor. So you can see this is a sample of the different sensor types. You can see the operating voltage is between 3.3 volt to 5 volt. We can see from here. So that means the maximum of the output voltage for the sensor is 5 volt. So the pins of the A0 and the digital, the maximum operation voltage is only 5 volt. It's more than 5 volt if we're going to damage the Arduino board. We look at this example of the circuit. This is LDR. LDR is the light dependence resistors. It's one of the light sensor. So there are the two types of connections, which is this is pull up, the different type of pull up and pull down connections. So please go to my lessons on 23rd of January to get further more information about these constructions. So this example that we can see that this R1 actually is a pull up resistor. Is in terms of these kind of connections. Well, the down one LDR is belong to the pull down LDR. So now we see if we have a voltmeter, we can connect the two terminals from the LDR, and we're putting the LDR face to the brightness LED conditions, and then we're able to get the ohms reading. Well, the other condition that we're putting the darkness environments, so we can measure that the ohms will change according to the brightness of the conditioned environment. So how are we going to get this information? Actually, this circuit actually operates under called voltage divider rules circuit. So this is the equations. So when the internal resistors of this LDR change, the voltage output will be going to change according to the voltage divider rule. So normally the voltage input from here, we actually require to connect from the Arduino, whether use 5 volt or 3.3 volt. Now, this table actually to help us, how are we going to collect the data in order we're able to write the C code to do the decision making and based on the incoming analog data, in order we can display whether now is a daytime or is a nighttime. So same things, we can try to construct the circuit or by using the voltmeter. The voltmeter connect in this way, and then we fill in the ohms when we are putting the LDR at the different conditions, like 8 o'clock morning, 10 o'clock noon, 2 o'clock afternoon, 4 o'clock, and until the night time. So we have ohms here, and also we're able to measure the voltage output using a voltmeter. Now we can see another sensor. This is another pH sensor. This is already given by this spec, which is this pH sensor driver. It will give us a voltage reading when at the specific of the pH value. This is another line follower sensor. All right, QRE1113. It's also is the output is actually the analog sensor, analog data, and an output voltage. Now this is another ultrasonic sensor, also to find to find what the distance in object. This analog sensor, other fruits ALS PT19 analog light sensor. So these are the few examples I'm showing here. There are still many different types of the analog sensor in the market. This is another experiment you can set out on this way. In order we have decimal data, later on we can see we're able to write a programming based on the incoming this analog data and do the decision making. So first of all, this we can see that this is actually is a EC meter. It will measure the condition, the lux outside of the conditions. So this is another voltmeter to measure the sensor, the voltage sensor, the voltage data. So this is we can see that this is a lux reading from this reference meter. They measure and let us know. Now this is the data actually from the output of the LDL. So we collect this data. So now we have the data, our real human data, human reading of the lux data, proportional to the analog of the sensor data. So that means when this output, we receive this output from the sensor data, meaning that our human data display is the lux initial is 20. Now we need an Arduino to process, to convert the analog data into the digital data, in order we're able to do the decision making and display now human being the data is 20 lux. Now again, you can try out using these simulations. All right, these simulations, we're able to get the digital data that we want. All right, so this is output voltage data. We can use this variable register to behave the output voltage of an LDR. So now look at the ThinkerCAD software here. So this is a ThinkerCAD is already a draw in the Tinker. This is actually a display voltage. So as we can see that the voltage now we want is about 1.8 volt. 1.8 volt. So when you see the simulations, here adjusted already 1.8 volt. So it's roughly about 368. 368. So that means it's 368 here. 368. So next, try another example. Let's say this is about 3 volt. 3 volt. Okay, now I try to adjust this one into the 3 volt. So yeah, the value is about 613. So 600 is our digital data. 613 reflective. That means this is our human data. The lux power is actually 30. But well, the computer language is 613. Now, if we have this data, all right, let's say we have this data, we just amend from the previous lesson using while loop. All right, the while loop, we have this information. Assume that this value is somewhere in between. In between, I put it when the data, the digital data is larger than 350 or less than 370. So it's in between this value. Then I display the lux is about somewhere around 10.1. So this is how we try to collect the digital data in order we're able to put into our programming. This data helps us to convert or to translate the analog data information into our human data that we want. So are you going to use the while loop for programming? Yes, of course. Please go to this video in the last lesson, this tutorial. You will familiar, you know how to get from this example to change it, to amend it, to improve it, and to the programming that you want it. Next, look at another temperature control. We can see this is a market of the temperature control button. We can see this. There are many different types. This is actually also using a variable register. So assume that this when this button is adjusted in this angle, somewhere in angle, is this 50 represent a 50 degrees Celsius along control and 50 degrees Celsius. Now 100 as indicator here represent that we would like to control in a 100 degrees Celsius. So this is an example of a variable register in the market. Is normally the adjustment of this variable register maximum is not more than 360. But some yes. But in this application, we better get some data which is not more than 360 degrees when we do the tuning. Now example, we can see that there's a CAD here, actually is as an indicator. So we assign first that at what certain degree we would like to, what kind of temperatures we want to control. From here, the example that we say that we maximum we like to control is only 180 degrees Celsius. So this is a position that difference of the temperatures that we want to go to control. So again, same thing, we use ThinkerCAD to simulate what is the digital data in order we can do the temperatures control. So here this is a 60 temperature degrees Celsius, 80 degrees Celsius. But this is all is analog output, analog output data. We still need to do some experiment to correct the digital data. Same thing, come up with this programming. In this programming to convert the analog data into the digital data. So plot this table. You can see this table. Temperatures on the variable register that already from the indicator over there. So 0, 60, 80, 100, 120, and 180. So this is the decimal data from the simulations. Now try to go to see from these simulations. This is actually from the past example. Okay, now let's say that here this is actually 60 degrees Celsius control, 60 degrees Celsius control. All right, so it's about 860. So it's about that 860, and let's say here is 880. So you must try to tune the variable register at a different angle, which is related to the temperatures that we want to display. This is all the decimal data that has been collected. So we can please get back to the last lesson from this YouTube. To understand this lesson, then you know how to modify this programming based on this table of the informations. So this means that I'm here show that between 880 to 1024 actually is in between. Is my decimal number is in between this value, then that is a control under 60 degrees Celsius. And this also in between this value you control at this degrees Celsius. All right, this is from the past lesson. The previous YouTube lesson, you can see from that. So we just get from this same programming, just modify the value, the condition value here, 800, and this also 1000. You to change all these value, and then based on inside what are the tasks that we want to going to do, then we just change the programming accordingly. And the second one, you can see from the second one, also same thing, just change the value of the condition here to 695 and let's say 880. And here, please be careful here. This also need to change because this one we would like to see is yellow color under these conditions. Yellow color LED is turned on. So this you need to change to high, and this one emanate change to low. And also the word here change to the yellow LED is on. All right, thank you for watching this video. I hope you enjoy it and you're able to understand, to do further better. Thank you.